Hi, good day. Welcome in today's episode of DepEd TV. I am Sir Jason Flores, also your math buddy, and I will be here to help you in developing your logical reasoning and critical thinking skills. Congratulations, as we are now in the 7th learning competency of our Mathematics 10. We have gone this far, dear students. Hence, bear in mind that the mastery of the skill is significant to have a smooth progress in the succeeding lessons. So buckle up as we move on to our lesson for today. For this lesson, we are going to learn and discuss the formula in finding the sum of finite and infinite geometric series. Specifically, we are going to find the sum of terms of a finite geometric sequence and find the sum of terms of infinite geometric sequence. How could we do this? Let us consider the geometric sequence 3, 6, 12, 24, and so on. To find the sum of the first 5 terms of the geometric sequence, perhaps we can simply generate the 5 terms, then add them. That's 3 plus 6 plus 12 plus 24 plus 48 is equal to 93. That was pretty easy, right? Let us try another example. Find the sum of the first 5 terms of the geometric sequence 7, 14, 28, and so on. Basically, we need to identify first the common ratio of the sequence to generate the next terms of the sequence, as what we have discussed in the previous episodes. So the common ratio R is equal to a sub 2, which is 14, divided by a sub 1, which is 7. The common ratio is equal to 2. For that reason, the first 5 terms of the sequence are 7, 14, 28, 56, and 112. What shall we do next? Add the terms to find the sum. That is 7 plus 14 plus 28 plus 56 plus 112, that is equal to 217. But take note of this essential question. What is the sum of the first 10 terms? First 15 terms? And first 20 terms? Are we still going to generate all the terms? Yes, and we can do it using geometric series. Why? It is because geometric series refers to the sum of the terms of a geometric sequence. Again, geometric series refers to the sum of the terms of a geometric sequence. Therefore, the formula in finding the sum of the first n terms of a finite geometric series is S sub n is equal to a sub 1 times the quantity 1 minus r raised to n all over 1 minus r. Again, the formula in finding the sum of a finite geometric series S sub n is equal to a sub 1 times the quantity 1 minus r raised to n all over 1 minus r, where S sub n is the sum of the first n terms. A sub 1 is the first term, n is the number of terms, and r is the common ratio. To find the sum of the first 5 terms of the geometric series 7, 14, 28, and so on, we will use the following solution. To do that, let's substitute the given values in the formula. Our given a sub 1, or the first term, is 7. Our n is equal to 5. The common ratio, again, that's a sub 2 divided by a sub 1. Our a sub 2 is 14 divided by our a sub 1, which is 7. The common ratio is 2. And we are looking for the sum of the 5 terms. Let's substitute again the values. For s sub n, that will be s sub 5 is equal to, our a sub 1 here is 7 times the quantity 1 minus our r, again, that's 2 raised to n, which is 5. Okay. Divided by our 1 minus r, again, our r is 2. S sub 5 is now equal to 7 times 1 minus 2 raised to 5. You have to multiply 2 by itself 5 times. Will give you 32. Over 1 minus 2 will give you, okay, that's negative 1. Moving on, we have s sub 5 is equal to 7 times 1 minus 32 is, yes, negative 31 divided by negative 1. Then we have s sub 5 is equal to the product of 7 and negative 31, that is, okay, that's negative 217, negative because we are multiplying numbers with unlike signs, divided by negative 1. So our a sub 5 now is negative 217 divided by negative 1 will give us positive 217. Positive since we are dividing numbers with like signs. Thus, the sum of the first 5 terms of this geometric sequence is 217. Now, it's time to level up your learning with another example. Find the sum of the first 7 terms of a geometric sequence where the first term is 3 and the common ratio is 4. The given a sub 1, or the first term is 3, our n is 7, our r is 4, and again, we are looking for the sum of the first 7 terms. Now, let's substitute these values to the formula. S sub n is equal to a sub 1 times the quantity 1 minus r raised to n all over 1 minus r. So that's s sub 7 is equal to a sub 1, which is 3, times the quantity 1 minus r, again, is 4, raised to n, which is 7, all over 1 minus r, which is 4. Then you will have s sub 7 is equal to 3 times the quantity 1 minus 4 raised to 7 means you have to multiply 4 by itself 7 times. So that's 16,384 all over 1 minus 4 will give us negative 3. Moving forward, we'll have s sub 7 is equal to 3 times 1 minus 16,384 is correct. That's negative 16,383 divided by negative 3. Then we have s sub 7 is equal to the product of 3 and negative 16,383 will give us, okay, negative 49,149 divided by negative 3. Our S sub 7 now is equal to, correct, that's 16,383 positive, since we are dividing these two numbers which have like signs. So thus, the sum of the first 7 terms of this sequence is 16,383. With that activity, we can solve the n terms of the geometric sequence using the formula we have used. At this point, we will try to apply simple mathematical equations in our daily lives, particularly in saving. In this activity, let us try to double your money in a bamboo bank. Joey saves an amount in his bamboo bank each week. To make it fun, he doubles whatever amount is inside the bamboo bank for the next week. On the first week, he saves 1 peso. On the 10th week, how much will be in the bamboo bank in all? Using this table, we can see in the first week, Joey saved 1 peso. For the second week, it became 2 pesos. For the third week, it became 4 pesos. And in the fourth week, it became 8 pesos. The total savings can be computed by 1 plus 2 plus 4 plus 8 and so on up to 512. That is S sub 10, or the sum of the first 10 terms or savings. The given are A sub 1, which is 1, the common ratio, which is 2, and we're looking for the sum of the 10 terms. Using the formula, S sub n is equal to A sub 1 times the quantity 1 minus r raised to n all over 1 minus r. Let's substitute the values to the formula. We will have S sub 10 is equal to 1 times the quantity 1 minus 2 raised to 10 all over 1 minus 2. S sub 10 is equal now to 1,023. Thus, after 10 weeks, Joey can save 1,023 pesos. Moving forward to the next task. Find the sum of the terms of the geometric sequence 1, 1/2, 1/4, 1/8, 1/16, and so on. But wait! How can we get the sum of the terms of the geometric sequence, because these terms are infinite? Is it even possible? Yes, and we will learn it using this example. The rectangle was divided into various portions such as 1 unit, 1/2 unit, 1/4 unit, 1/8 unit, 1/16 unit, and so on. The rectangle can still be divided into smaller rectangles up to infinity. If the areas of all rectangles are added, this will give a sum of 2 square units. This scenario indicates that we can still find the sum of the terms of an infinite geometric sequence. In a mathematical statement, we can write the sum of the areas of the rectangles as follows: 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1 over 32 and so on will give us 2. 2 is the sum of terms of an infinite geometric sequence, while the ellipsis is a set of 3 dots that indicates infinity. Based from the example, we can have the formula s to infinity is equal to a sub 1 over 1 minus r, where s to infinity refers to the sum to infinity, a sub 1 is the first term, and r is the common ratio. Now, let us test if the formula is correct. That's 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1 over 32 and so on will give us 2. The solution, the first term or a sub 1 is 1. The common ratio, that is a sub 2 divided by a sub 1. Our a sub 2 is 1/2 divided by 1. Our common ratio is 1/2. Now, let us substitute these values in the formula. Sum to infinity is equal to a sub 1 divided by 1 minus r. The given again is a sub 1 is 1 and the common ratio is equal to 1/2. So that's sum to infinity is equal to our a sub 1 is 1 divided by 1 minus our ratio again is 1/2. Then we'll have a sum to infinity is equal to 1 divided by 1 minus 1/2 will give us, okay, that's 1/2. Since our denominator is a fraction, we will get the reciprocal of the denominator, then we will proceed to multiplication. So that's sum to infinity is equal to 1 times the reciprocal of your 1/2, that's 2 over 1. So the sum to infinity is equal to 1 times 2 will give us 2, and your denominator here 1 times 1 will also give us 1. So therefore, the sum to infinity is equal to 2. Bear in mind that this formula is applicable only to infinite geometric series when the common ratio is lesser than 1 but greater than -1. Let's proceed to the next example. Find the sum of an infinite geometric sequence whose first term is 5 and the common ratio is 1/4. Our values for a sub 1, that's 5, and the common ratio is 1/4. Now let's substitute these values in the formula. Sum to infinity is equal to a sub 1 divided by 1 minus r. So that's sum to infinity is equal to our a sub 1 is 5 divided by 1 minus our r here is 1/4. The sum to infinity is equal to 5 divided by 1 minus 1/4 will give us, okay, that's 3/4. Again, our denominator is a fraction, so we will get the reciprocal of your denominator. That's 5 times the reciprocal, which is 4/3. So the sum to infinity here is equal to 5 times 4 will give us 20/3. Thus, in this sequence, the sum to infinity is equal to 20/3. Well done! And I believe that you have followed our discussions because we will be doing another round of mathematical cracking of equations and questions. For that, let's check for what you have learned by answering the following questions. Number 1. The sum of the terms of a geometric sequence is called. Correct, that's geometric series. Number 2. To find finite geometric series, use the formula Alright, that is S sub n is equal to a sub 1 times the quantity 1 minus r raised to n all over 1 minus r. For the next numbers, 3, 4, and 5, use the sequence 3, 6, 12, and so on. Determine what is the first term. Correct, that's 3. How about the common ratio? Right, 2. What about the sum of the first 5 terms? Correct, that's 93. Do you have the same answer with me? Of course! Well done! Let's boost up your learning more with another assessment questions. Find the sum of the terms of each of the following infinite geometric sequences. Number 1, 12, 6, 3, and so on. The answer is 24. Item number 2, 125, 25, 5, and so on. The correct answer is 625 over 4. We truly have a wonderful math time on screen. For additional learning activities in Mathematics 10, please don't forget to like, share, and subscribe to the DepEd TV official YouTube channel. And that concludes our lesson for today. On the next episode, you are going to learn how to perform division of polynomials using long and synthetic division. And again, this has been your teacher Jason Flores Oso. Bear in mind that learning math is and will always be easy. Be also, be awesome. Only here on DepEd TV.